Hey guys, so let's discuss new question, which is how do you manage token limits? Okay, so LLM have a maximum context window. You know that the context window is limited there. Okay, so meaning they can only process a limited number of tokens at once. So for example, they can process 8k tokens, 8,000, 32,000, 128,000 tokens. Okay, if input becomes too large, so request fails, latency increase and cost increases. Okay, if the input you're sending is itself is very large, okay, it has consumed all the tokens, let's say, then how he will generate the response? Okay, how he will generate the token, extra tokens, because the limit is this one only. So token management is very important in system design problem in AI applications. And what is token? So token is a small piece of text, you can say. Okay, a small piece of text. Example, so for example, if Java is awesome, so here Java is awesome, they're tokens. So now problem example, suppose user send long chat history. Okay, you know that we send with the question, we send the context also. So long chat history, multiple PDFs, huge prompts. So token total token is 150k token, let's say. Okay, but model supports 32,000 tokens only. So here we need optimization. And common techniques to manage token, we will be discussing 10 techniques. Okay, after that we will discuss 4 advanced techniques. So the first one is chunking. Split large documents into smaller chunks. For example, if you have one PDF, so just break them into different chunks, 1, 2, 3, and instead of sending entire document, retrieve only the relevant chunks, like the chunk number 1 is related to your question, so send only that one. So very important in RAG system. Now the second one is Retrieval-Augmented Generation, RAG. Okay, so here instead of sending all data, retrieve only relevant context. For example, user asks what is the refund policy, so system will retrieve only refund related chunks and not the other one. Okay, instead of whole PDF. Now what will be the RAG flow? So RAG flow will be user query. Okay, then we will do embeddings on that. Then it will search in a vector, it will retrieve top chunks, and then it will send it to LLM. Now the third one is conversation summarization. So long chat histories consumes huge tokens. Okay, so what is the solution? Summarize older conversations which is not required anymore. So for example, instead of 100 previous messages, just store user discussed payment issues earlier. That's it. Okay, now sliding window context, this is the fourth one. Keep only recent messages. For example, keep last 10 messages only and older messages dropped or summarized it. Okay, very common in chat systems. Fifth one is context compression. So compress the context. Compress retrieved document. For example, original has the 5-page policy document. Okay, so compressed one, short summarized context before sending it to LLM. So comprised it. The sixth one is token budgeting. So allocate token. Okay, so for example, reserve token carefully. For example, the components, you have different components like system prompt, 2,000 token will be reserved there. Okay, for chat history 4,000, retrieved document 8,000, user query 1,000, and output reserve 2k. So if you reserve the tokens for each components, that also be good thing, right? Why reserve token or tokens, output tokens? So if input consumes entire context window, model cannot generate response because he doesn't have the extra tokens. Seventh one is smart retrieval. So retrieve top 3 relevant chunks instead of 100 chunks. So what is the improve here? So token efficiency will get improved, latency and cost. Prompt optimization. So whatever prompt you are sending, optimize it. Okay, so reduce unnecessary prompt text. So like very long repetitive instruction if you have, so that is the bad thing. Okay, so what will be the good thing? Short optimized system prompt. Now the ninth one is multi-step processing. So instead of one giant prompt, okay, break task into smaller stages. So example, step 1 is retrieve data, step 2 is summarize the data, and step 3 is final answer. 10th one is use larger context model carefully. So some models support 128k, 1 million context also. Okay, but the larger context is slower, you just remember it. Okay, so it is slower, it is expensive, it is higher latency, so still optimize tokens. Now example, enterprise chatbot flow. Let's say you have an enterprise chatbot flow. Okay, so user query will come, it will retrieve the relevant document, it will summarize the old history. Here he is doing the optimization, apply token budgeting, and then send optimize to prompt. Okay, so here it is doing 3 places, it is doing 3, and here also it is doing the optimization part. So now example calculation. Okay, suppose a model support 32,000 tokens. So you just allocate system prompt 2000, chat history, retrieve documents, user query, and output reserve different tokens. So total will be 32,000. Now I told you that we will discuss 4 advanced technique also. So the first one is semantic compression. What is semantic compression? Use a smaller AI model to compress context. Okay, you have a smaller AI model and larger AI model. So to compress the context, just use this smaller AI model. Hierarchical summarization. So large document summarized in layer. Now memory systems. So again here long-term memory separately and retrieve only needed memory. Caching. Okay, so you just reuse the caching, and you will use caching for what? For embeddings, for summaries, and then for prompt templates. Okay, now what challenges you will be face here? So the first one is large PDF. What you will do? Chunking is the solution. Long chat history, summarization is the solution. Expensive prompts, compression is the solution. Then hallucination, smart retrieval is the solution. And slow inference, so smaller context is the solution. If you give the smaller context, then the inference system will generate the result quickly, right? So real world system use ChatGPT. What it is using? It is using sliding window and summarization. And enterprise RAG system, it is using chunk retrieval. AI agents, it is using memory retrieval. And code assistant like cursor and all, it is using relevant file retrieval. So that's it. Thank you.